Okay, today we're going to take a look at section 5.3, interpreting and sketching graphs. I kind of like this section. It's sort of a nice break from the mathing part of it, and it's just a nice opportunity for us to review the types of graphs that we use and work on a little bit of vocabulary. Okay, so we can tell a lot from a graph. The title tells us a lot, and if you've taken Science 10 yet, okay, you should be really familiar with having a title that you underline and then having your y-axis labeled with units if possible, and your x labeled with units if possible. And then we're really going to talk about increments here. So going up by a steady amount. Doesn't have to be the same amount on the y-axis as it is on the x-axis, but that we're being steady all the time. Okay, so this is just a graph that shows us the temperature change from midnight. This has got the military clock going midnight till 2 o'clock here, or to 8 p.m. sorry. Okay, so here we go. From the graph we can see that it warmed up and then it cooled off, which makes sense, right? Midnight warms up during the day till noon, and then as we move to 8 o'clock the temperature goes down a little bit. Okay, so if I asked you what the highest temperature was, that's a pretty easy thing to see. Okay, here's the temperature on the side here. We look here, and the highest temperature was 8 degrees, and that happened at noon. Okay, so if I asked you to write that as an ordered pair though, let's remember that this is our x-axis and this is our y-axis. So you would write at 1200 hours, it was 8 degrees, and that would be your ordered pair. And so that's kind of important here because it's a little bit weird that we're not always using numbers. Sometimes we're going to be using words, and it's just not going to be like the regular graphs that we worked a lot on in grade 9. Okay, so now we're going to move to this next one. So I'm going to do an example, then on the next page we're going to work through an example. So this is the costs and masses of various bags of popcorn. Okay, and here's how you know I'm an old lady. When I've typed it like this: each point on the graph represents a bag of popping corn, because I've turned into my nana. Explain the answer to each question below. Which bag is the most expensive and what does it cost? So this is where we have to know, okay, here's cost on this axis here. So we're going to go up here where it looks to be the most expensive, and that looks like it's going to be bag C. And what does it cost? Well, it looks like these increments are going up by 1 every single time, so it looks like it costs $7, and that's indeed what I've answered here. Bag C is $7, it's the most expensive. Okay, now this one says which bag has the least mass. So now we're going to go down to the x-axis. Least means the smallest amount. So here looks like B. Okay, B has the least mass, and this is going up by increments of 200, it looks like. So here is be 400 to 600. It's right in the middle, so I would say around 500 grams, and that's what I've answered over here. Which bags have the same mass? So we're looking here on the x-axis, and we want to see bags that are sitting sort of one on top of each other because they have the same x value, right? The same mass. So D and E, and they are around 1,800 grams. Which bags cost the same? So now we're looking at our y-axis, and we're looking for ones that are sitting on the same, and that is A and E, and they cost around $4. Which bag, C or D, is better value for the money? Okay, so we're looking at C and D. Okay, so C is more expensive but has less in it. D is less expensive and has more, so D would be a better value. Okay, so that's all we're doing in this section, is just looking at graphs and seeing what kind of information we can glean from the graphs. Okay, so if I gave you this, you try. Okay, we've got a graph. It's titled Age and Heights of People. So the y-axis, okay, or a range as we're going to start to talk about it, goes on this axis, and it's in centimeters. Age, of course, is going to be in years, and that's going on our x. Okay, so it says which person is the oldest. So we're going to look here on age. Okay, the one that's furthest along at 18 years is G. Okay, so which person G. Okay, it doesn't ask us how old they are, but let's keep going here. 18. Which person is the youngest? Okay, so we're looking at age here, and here we go. Right here looks like person A. And how old are they? Well, we wouldn't say 0. Okay, let's try this. Let's use like correct. I'd say it's a newborn. Person A is a newborn. Which two people have the same height? So now we're looking at the y-axis here. The two people that have the same height are B and C. B and C. What height are they? Looks like they're 100 centimeters tall. Okay. which person, B or C, is taller for their age? Well, B is younger, okay? If they're the same height, B is younger. That means that person B is taller for their age. Oh, I missed a question here. For age. Which two people have the same age? Let's go back to that one. So the same age right here. E and D are both 10 years old. E and D, 10 years old. And does this graph represent a function? This is important because now we're going back to previous sections. If it is a function, no x values repeat. So we're going to look along the x values here and look. If you drew a line through here, E and D, okay, both have the same x value. If I asked you for the ordered pair of E, you would tell me 10 and 150 centimeters, okay? And if I asked you for the ordered pair for D, you would tell me 10 and 125. And you can see clearly when you do that, that the x value is repeated. So is it a function? No. Okay, if I asked you why, the x values repeated. And that is exactly an excellent answer for me. Okay. Describe a possible situation. So we've got a volume of water in Amiko's water bottle. Okay, she started out, she had 500 milliliters in her water bottle, and it looks like obviously in 10 seconds she drank all of it. What happens here? Well, it looks like she filled it up all the way to 1,000 milliliters, and then because there's no change in the volume, looks like she just set it down. Okay, so these are going to be like your own interpretation. What I want you to do is I want you to tell me, I want you to be using the volume and the time. Okay, so right here you'd say it started off, okay, with 500 milliliters in 10 seconds. Do you see how we described that movement here? She drank 500 milliliters. Okay, it took around, and then I would say around 5 seconds to fill up her water bottle to 1,000 milliliters, and then for the next 15 seconds, she left her water bottle and didn't drink out of it. Okay, so I've given you a little scenario here. You can come up with your own. Okay, so what we're going to do here now is I'm going to ask you to describe a possible situation. So there's volume of gas in Winston's motorcycle, and I will have these written up on online for you. I want you to give these a whirl, but let's just talk through it. Okay, so it looks like Winston starts with 15 liters of gasoline. And so then he drives for 2 hours, okay? Obviously he's driving because he's using gas. And as he went and used gas for 2 hours, he used 10 liters of gas. He stops for, and it looks like 1 hour. So maybe he was visiting a friend for 1 hour and used no gas. And then it looks like in about, and I don't know how you want to describe this, but I would say in 10 minutes, he fills up his tank to 20 liters of gas. Okay, that would be a possible situation. Day trip from Athabasca to Kikino, so that means they left and then they returned. You're coming back to the same place, right? Okay, because you're distance from home. So in the first, let's see, in 2 hours, they drove 140 kilometers. That would be a great way to describe that. They visited 4, and then it went from 2 to 3. So for 1 hour, they stopped and visited. Okay, they drove, and then you have to figure out from 140 to about 90. So they drove 50 kilometers in 45 minutes. They stopped and rested, okay, or had lunch or whatever for another 45 minutes. And then in the remaining hour, they drove the rest of the 90 kilometers home. So that would be one way to describe that. Okay, so we're going to stop there. I want you to take a look at these notes, and then I'm going to post a fairly straightforward assignment today.